Let's look at some examples for calculations involving pH. And before we get started into our calculations, we know that pH is equal to negative log of the concentration of H plus. And on the other hand, we have pOH, which is equal to the negative log of the concentration of OH minus. So using both of these formulas, we should be able to find the pH for all of the examples that we are going to look at today. So this first example is again asking us for the pH of a solution, and they're giving you the mass of this acid, so hydrochloric acid, and it's dissolved in 1.5 liters of water. So first of all, the acid that I'm given, I have to identify what kind of acid it is. I just want to make sure that it is a strong acid, and I know that HCl is a strong acid. And what I mean by strong acid, if HCl is dissolved in water, it is going to break apart completely into its ions. So HCl is going to become H plus and Cl minus, and completely so. So because this is a strong acid, all of the HCl present will then break apart into H plus and Cl minus. Okay, so given that information, we know that if we are able to find the concentration of HCl, we will know the concentration of H plus. And that's how I would find the pH. So I know that my pH formula, let me use a different color for this. So my pH formula, just like I just mentioned in the previous slide, is negative log of the concentration of H plus. So knowing the concentration of H plus can then allow me to find the pH. How do we get there? So it might take us a few steps to do this, but because I'm given all of this information in my question, I can easily solve for it. So let's start off with our 25 grams. That is the mass of the HCl that I'm given in the sample. And I want to find the concentration of HCl. And concentration is moles per liter. And because I'm given the mass of HCl, I can use my molar mass to find the moles. So I know that for every 1 mole of HCl, it weighs 36.46 grams. And if I do this or solve for this in my calculator, I would just have to do 25 divided by 36.46. And this gives me 0.6856. And I'm just going to write this number down on this PowerPoint, but in my calculator, I'm going to keep the full number there so that I can use it in further calculations without rounding. So I've got my value in moles here, and I need to find the concentration, which is moles per liter. So I would take my value of moles, 0.6856 moles, and divide it by the volume that's also given in this question. So if I do 0.6856 moles divided by 1.5 liter, I will get 0.45712 moles per liter. Now let's go back to our acid here. So because I know the concentration of HCl, because this is the concentration of hydrochloric acid, this concentration, 0.45712 moles per liter, can tell me the concentration of the H plus ions as well. And it is a 1-to-1 ratio. So what I mean by that is that for every 1 mole of HCl, I'm going to have 1 mole of H plus. And because that is the case, I can then use that to find my concentration of H plus. So in this case, pH is equal to negative log of 0.45712. So if I solve for this, I'm going to get a pH of 0.33. And notice that there's 2 significant digits in my question. My answer is also going to have 2 significant digits. Moving on to the next example, again solving for pH, but in a different way. So in this question, they're asking to find the pH of a solution of two different acids mixed together in a certain volume of water. So just like we did in the previous question, let's identify the acids that were given. So HNO3 is a strong acid, which I know then means is that it breaks apart into its ions. So if it's in water, it'll get broken down into H plus and NO3 minus. Now the other acid, HCl, is the same one that we saw in our previous example. So HCl also breaks apart into H plus and Cl minus. All right. Now let's move on to the values that were given in this question. It tells us that there is 1.2 moles of HNO3 used and 1.7 moles of HCl. And again, because of our ratio, because all of this HCl becomes H plus, we know, and H plus and Cl minus, we know that because there's 1.7 moles of HCl, there will be 1.7 moles of H plus. Similarly, because we know that there's 1.2 moles of HNO3, there will be 1.2 moles of H plus. But remember that when I'm solving for pH, I am solving for, or I will have to solve for the concentration of H plus. So just knowing the moles of H plus doesn't quite get me to the answer quite yet. So what I would then have to do is find the concentration, or the moles per liter of H plus. In order for me to do that, all I would need to do is add up the moles of H plus from each acid. So 1.7 moles plus 1.2 moles, and divide it by 1,000 liters. So if I do this calculation, I'm going to get the concentration of 2.9 times 10 to the power of negative 3. This is the concentration of H plus. If I take this value and I sub it into this particular formula, and I do negative log of 2.9 times 10 to the negative 3, and I'm making sure that I'm putting brackets around any number that has scientific notation, I should get a pH of 2.5, but because I know that this number has two significant digits, this number has two significant digits, and then this number has one significant digit, I'm going to round my answer so that it has one significant digit as well. So the pH is going to be 3. Now here's another example, and this time they're giving us the pH of one solution and asking us after a dilution what the pH would be of the resulting solution. So instead of giving us, like we've seen before, instead of giving us all the values for C1 V1 is equal to C2 V2, what they're instead giving us is the pH of 4, a volume that we can say is V1, and a volume that we can say is V2. We don't have the concentration of C1 yet, and we don't know the concentration of C2. But because I'm given the pH of C1, I can find the concentration of that solution. How do I do that? I know that the concentration of H plus is equal to 10 to the power of negative pH. So the concentration of H plus is going to be 10 to the power of negative 4 moles per liter. So now what I have here is my value of C1. So I've got C1, V1, as well as V2, and they're asking you to find C2. And using C2, we can then solve for the pH of that solution. So let's do our dilution calculation. So C1V1 is equal to C2V2. C1, I know, is 10 to the power of negative 4 moles per liter. V1 is 0.01 liters times C2, which we don't know, and V2, which is 1 liter. So what I will end up having is 10 to the power of negative 6 moles divided by 1 liter is equal to C2. Now the question is not asking us just to find the resulting concentration, it's asking us to find the resulting pH. So what we can do is take this value of concentration, 10 to the power of negative 6, and put that into our formula for our pH. So pH is equal to negative log of the concentration of H plus. And in this case, 10 to the power of negative 6 moles per liter is the concentration of H plus. So when I solve for this and I put this into my calculator, I am going to get a pH of 6. And that's okay because the concentration of this solution has changed. And we know we've solved for the second concentration, and then we have to again solve for the pH with that second concentration. The significant digits in the numbers in my questions are all 1, which means that the significant digits of my answer has to be rounded such that there's 1 significant digit, which this number does have. Now let's look at the last question. In this case, we are asked to find the concentration of an NaOH solution that has a pH of 12.7. Now, NaOH is a base, and it is a strong base, which means that it is going to, just like we've learned about for strong acids, break apart completely into its ions in a solution of water. So NaOH breaks apart into Na plus and OH minus. Now you might be thinking, with pH, we don't really know, or the only thing that we can find with our value of pH is the concentration of H plus. And in this case, that doesn't directly help us to find the concentration of NaOH. However, what we do know is that pH plus POH is equal to 14. So if I wanted to find the pOH of this particular solution, I can do 14 minus 12.7, and I can find that the pH is the pOH is equal to 1.3. So knowing the pH can then help us identify or find the concentration of OH minus. And the concentration of OH minus is equal to 10 to the power of negative POH. So the concentration of OH minus is equal to 10 to the power of negative 1.3 moles per liter. And if I place this number into my calculator, I am going to get 0.0501 moles per liter. Okay, and now that I have the concentration of OH minus, so I have 0.0501 moles per liter, we can sort of work backwards. If we know that the concentration of OH minus is 0.0501, then the concentration of NaOH must be the same because we know that it's a strong base and we know it breaks apart completely into Na plus and OH minus. So knowing the concentration of my OH minus will help me find the concentration of the base to begin with. And my final answer should have 3 significant digits, since that is the number asked for us in the question, and this value does have 3 significant digits.